Split air conditioners maintenance guidance. Split type air conditioners maintenance guidance. This video introduces the universal maintenance procedure of split system air conditioner. There can be some differences between the units in this video and the ones of yours. This video is divided into 3 parts. The first is checking the running parameters. The second is the replacement for the key components. The third is the maintenance guidance for the air conditioners. Now, you can use the remote controller to check many running parameters of the units by special operations, which can make you know the system more clearly for troubleshooting. When the unit is running, press LED or Do Not Disturb button 3 times, and then press Air Direct or Swing button 3 times. Waiting for several seconds, the unit will give out a long beep and start to show the parameters. The unit will show parameter code 2 seconds and then show the value. This table lists all the parameters that you can check via this mode. During this mode, you can press only LED or Air Direct button to check next or previous information. Any other button is pressed, the unit will quit this mode and back to normal display. During maintenance, you could possibly replace the components as below: compressor, high pressure valve assembly, reactor, fan motor, main PCB, and EEV, electronic expansion valve. Note: when you decide to change a PCB, make sure there is not any short circuit to the ground of any component which is connected to the PCB. When error occurred, the error code will be shown on the display board of the indoor unit. This table lists all the error codes you may meet. You should pay attention to the states of running light and timer light to tell the error code if the indoor unit has no digital display. Take E3 and F3 as examples. The running light will flash 4 times every 4-second interval. The timer LED will be off, E3, or be on, F3, if the unit has no digital display. Caution: please operate the maintenance for your air conditioner according to the service manual. Measure the voltage. Caution: all other operations must be carried out without the power connection except for checking the voltage and error codes. For safety reason, the voltage should be checked before operating the unit. Measure the voltage between P and N with multimeter. If the value is lower than 36 volts, the maintenance operation can start. EEPROM chip error. When the display board of indoor unit displays E0 or F4, which indicates EEPROM chip error. EEPROM, a read-only memory whose contents can be erased and reprogrammed using a pulsed voltage. Malfunction decision conditions. The main chip of indoor or outdoor PCB cannot receive the feedback from EEPROM chip. Shut the power off, then turn it on 2 minutes later. If it is still displaying E0 error code, replace the indoor main PCB. If it is still displaying F4 error code, replace the outdoor main PCB. Indoor-outdoor units communication error. When the indoor unit displays E1, which indicates indoor or outdoor units communication error, this failure could be caused by inappropriate wiring or main PCB error. Malfunction decision conditions. Indoor unit does not receive the feedback from outdoor unit during 110 seconds, and this condition repeats for 4 times continuously. Shut the power off, then turn the unit on 2 minutes later. Measure the voltage between S and N. Select voltage DC position, then connect the red pin of multimeter to N ports, the black pin to S port. If the air conditioner is operating normally, the voltage is moving alternately as positive values and negative values. If the voltage has always been the positive value, possible malfunction may occur on the outdoor unit. Main attention should be paid to the outdoor unit. Check the wiring of the outdoor unit, which includes the power wires and the interconnection wires between the indoor and the outdoor unit. Check the wiring of L, N and S of the outdoor PCB. Check the resistance of EEV, an electrical expansion valve. If the unit has one, make sure there is no any short circuits which could be damaged at the outdoor PCB. Check if the wiring of the electric reactors of the outdoor unit is well connected. Measure the resistance value of the reactor. The normal value should be within the range of 0 to 1 ohm. If not, replace the reactor. If the error still exists after the maintenance procedure above, replace the outdoor PCB. If the error still exists, replace the indoor PCB. If the voltage is a fixed value, possible malfunction should have occurred on the indoor unit. Main attention should be paid for the indoor unit. Check the wiring of the indoor unit, which includes the power wires and the connecting wires between indoor and outdoor units. Check the wiring of L, N and S of the indoor PCB. If error still exists after the maintenance above, replace the indoor PCB. If error still exists, replace the outdoor PCB. Zero crossing signal detection error. When the indoor unit displays E2, which indicates zero crossing signal detection error, this failure could be caused by erratic power supply or main PCB error. Malfunction decisions conditions. When PCB does not receive zero crossing signal feedback for 4 minutes or the zero crossing signal time interval is abnormal. Shut the power off, then turn the unit on 2 minutes later. If the error still exists, replace the indoor PCB. The malfunction of fan motor speed. When the display of indoor unit shows E3 or F5, there is malfunction of indoor fan motor speed, RPG motor or DC motor, or outdoor fan motor speed, DC motor being out of control. Malfunction decision conditions. When fan speed keeps lower than 300 RPM, RPG motor, for certain time, or fan motor feedback signal is abnormal, DC motor, the unit will stop and the LED will display the failure. The failure may be caused by 1. Wiring error. 2. Faulty fan. 3. Faulty fan motor. 4. Faulty main PCB board. Shut the power off, then turn it on 2 minutes later. If the error still exists, shut the power off, then check the fan. Rotate the fan by hand. Check whether the fan is blocked or rotating normally, and whether the screws which fix the fan have been tightened enough. If the fan is normal, check the wiring of the fan motor according to the wiring diagram. Commonly, there are two kinds of DC fan motors with different pins. First, DC motor with a 5-core pin, which has the control chip inside itself. The second, DC motor with a 3-core pin which has the control chip on the PCB. Check the fan motor for RPG motor, AC motor with feedback. This motor has 2 plugs. Separately, 3-pin plug connects to the power supply. 4-pin plug is used for signal transmission. If the connection is correct, pull out the 3-pin plug and check the resistance of the fan motor. The resistance value between red and black pin, white and black pin should be the same as the specifications of the motor. Change the fan motor if the values are abnormal. For DC fan motor with 3-pin plug, pull out the plug and check the resistance of the fan motor. The resistance value between each 2 pins should be equal to each other. If not, change the DC motor. Check the main PCB for AC motor with feedback. Turn on the unit and set it to the fan-only mode in high speed. Measure the voltage between red and black pins of the 3-pin plug in 15 seconds. If the value is lower than 100 volts, for models using 220 to 240 volts power supply, or 50 volts for models using 110 volts power supply, the main PCB must have a problem and need to be replaced. If the value of the voltage is normal, the fan motor needs to be replaced. If the error still exists, replace the main PCB. Examination for main PCB board. DC motor with control chip in itself. Turn the power on, measure the voltage between pin 1, pin 3, pin 4, pin 3 in fan motor connector in standby mode. If the value of the voltage is not within the range shown in the table, change the main PCB. If the values are all normal, change the fan motor. Open or short circuit of the temperature sensor. When indoor unit display E4, E5, F6 for multi-zone units only, F1, F2, F3, which indicates open or short circuits of the temperature sensor. Malfunction decision conditions. The LED will display the failure if the sampling voltage of temperature sensor is lower than 0.06 volts or higher than 4.94 volts. The error could be caused by 1. Wiring mistake. 2. Faulty sensor. 3. Faulty PCB. This is T1, indoor room temperature sensor. This is T2, evaporator temperature sensor. This is T3, condenser temperature sensor. This is T4, outdoor ambient room temperature sensor. This is T5, compressor discharge temperature sensor. Check the wiring of sensor for different main board. This structure is T3, T4, T5 sensors being integrated onto a sub-patch. The structure is T3, T4 being for the sub-patch, T5 inserted in the main control board. If the wiring of the sensor is correct, check the resistance value of the sensor. Pull out the plug and measure the resistance value of T1 and T2 sensor. The resistance value refers to the characteristic table. If not, change the sensor. If the resistance value is normal, replace the main control board. Refrigerant leakage detection diagnosis. When the indoor unit displays EC, which indicates the refrigerant leakage detection error, the failure could be caused by 1. T2 coil temperature of evaporator error. 2. Indoor main PCB error. 3. Refrigerant system error. Shut the power off and turn it on 2 minutes later. If the error still exists, check if there is cool air blowing out from the indoor air outlet. If there is cool air blowing out, check whether T2 sensor is well fixed and measure the resistance value of T2 to ensure the sensor works well. If the error still exists, replace the indoor PCB. If there is a refrigerant oil on the joint, apply soapy water or leak detector to check if the system has any leakage. If there is any leakage in the system, let out the refrigerant and repair the leakage. Then vacuum and recharge the refrigerant. Check the EEV, electrical expansion valve. If the unit has one, measure the resistance to check if there is any short circuit. If yes, replace the coil of EEV. Measure the output voltage to the EEV. The value should be the same as the table. If not, replace the outdoor PCB. If the error still exists, there may be blockage inside the system, especially the capillary. So change the whole high-pressure valve assembly. IPM module fault or IGBT overcurrent protection. When indoor unit displays P0, P4, which indicates IPM module fault or IGBT overcurrent protection, malfunction decisions conditions P0, when the voltage or fault pin of IPM is not 5 volts. The LED will show P0 and the air conditioner will be off. Malfunction decision conditions P4. The LED will show P4 and the air conditioner will be off if there is an abnormal feedback signal including voltage, currents, rotating speed and so on from the inverter compressor. The failure could be caused by 1. Wiring mistakes, 2. IPM error, 3. Outdoor fan motor error, 4. Compressor error, 5. Outdoor main PCB error, 6. System pressure error, 7. Bad ventilation of outdoor unit, check the wiring between the main PCB and the compressor. If the wiring is correct, check if IPM is operating well. Check the resistance value between P and UVW. Between N and UVW, the normal valve should be as mega-ohm order of magnitude, and each two valves are equal. Or we can check the conductivity between P to UVW and N to UVW. The positive conductivity, UVW to P, N to UVW, should be some value, and the negative conductivity, P to UVW, UVW to N, should be infinite. For other PCB board, please refer to the instructions for IPM check. If the result is abnormal, replace the IPM board or replace the main PCB. Check the EEV, electrical expansion valve. If the unit has one, measure the resistance to check if there is any short circuit. If yes, replace the coil of EEV. Measure the output voltage to the EEV. The value should be the same as the table. If not, replace the outdoor PCB. Check if ventilation of the outdoor unit goes well. Check if the outdoor fan operates well. Then find solutions according to the solution for the malfunction of fan motors being out of control. Check the resistance value of the compressor terminal and check if the compressor is working well. The normal resistance value of each two terminals are equal. If the resistance are not equal, replace the compressor or whole outdoor unit. If the error still exists, replace the outdoor main PCB. DC over voltage of over low voltage protection. When indoor unit displays P1, which indicates over voltage or over low voltage protection, malfunction decision conditions. An abnormal voltage rise or drop is detected by checking the specified voltage detection circuit. The failure could be caused by 1. Power supply error. 2. System leakage or block. 3. Faulty PCB. Check whether the voltage is normal. If the voltage is abnormal, stop the unit. If the voltage is normal, check whether the power wires of the terminal in, indoor unit and signal wires are good. If not, correct the connections or replace the wires. After confirmation that the wire is good, when the unit is in standby model, check if the voltage between P and N is around 310 volts. Then start up the unit and the compressor starts to running. Measure the voltage between P and N and see if it's within 220 volts to 400 volts. If the voltage is abnormal, replace the outdoor main PCB. After the maintenance above, there could be two cases. If the voltage is normal, check the wiring of the reactor. If the wire is well connected, measure the resistance value of the reactor. The normal value should be around 0 to 1 ohm. If not, replace a new reactor. If the error still exists, replace the outdoor main board.